8.2 The types of VPN. 8.2.1 Remote access VPNs. In the previous topic, you learned about the basics of VPN. Here, you will learn about the types of VPN. We have the remote access VPN. This allows remote or mobile users to securely connect to the enterprise network over the internet. That creates an encrypted tunnel between the remote user and the enterprise. It gives remote employees secure access to resources such as email, network applications, server, and files. Contractors and partners can be given limited access only to resources they need. That helps maintain network security while supporting remote work. Typically established dynamically or on demand when the user needs access. The remote user initiates the VPN connection. Common technology are IPsec VPN and SSL VPN. In this example, it shows that a remote user connects to the company headquarters through the internet. A SSL VPN tunnel encrypts traffic between the remote user and the enterprise network. The remote user can connect using a web browser for browser-based SSL VPN access. Cisco AnyConnect Secure Mobility Client for VPN client-based access. SSL VPN Gateway is located at the headquarters and it authenticates remote users, terminates the encrypted VPN tunnel, and provides controlled access to internal resources. The workplace resources can include servers, applications, files, and internal network systems. Traffic traveling across the public internet is encrypted and protected. So the path here is from the remote user connects to the internet, and then there is a SSL VPN tunnel, goes to the SSL VPN gateway, and then reach to the workplace resources. 8.2.2 SSL VPNs. When a client negotiates an SSL VPN connection with the VPN gateway, it actually connects using the Transport Layer Security, the TLS. TLS is a newer version of the SSL and is sometimes expressed as the SSL or TLS. However, both terms are often used interchangeably. SSL uses the public key infrastructure and the digital certificates to authenticate peers. Both IPsec and SSL VPN technologies offer access to virtually any network application or resource. However, when security is an issue, IPsec is the superior choice. If support and the ease of deployment are the primary issues, consider SSL. The type of VPN method implemented is based on the access requirements of the users and the organization IT processes. The table compares IPsec and SSL remote access deployment. And here we have a few features, such as we have the application supported. For IPsec is extensive. All IP-based applications are supported. For SSL, that's limited. Only the web-based applications and the file sharing are supported. There's the authentication strengths. For IPsec, it's pretty strong. It uses two-way authentication with shared keys or digital certificates. For SSL, it's moderate, using only one-way or two-way authentication. In terms of the encryption strengths, IPsec is pretty strong. It uses key lengths from 56 bits to 256 bits. And for SSL is moderate to strong, with a key length from 40 bits to 256 bits. In terms of the connection complexity, IPsec is medium because it requires a VPN client pre-installed on a host. For SSL is low. It only requires a web browser on a host. And then it has the connection option. For IPsec is limited. Only specific devices with specific configuration can connect. For SSL is extensive. Any device with a web browser can connect. Let's compare IPsec and SSL VPN. IPsec and SSL VPNs are complementary, not competing technologies. An organization can use IPsec, SSL, or both, depending on the remote access requirements. For the IPsec VPN that provides secure IP-based network connectivity, it's common when users need broad access to the corporate network, often use dedicated VPN client software. For the SSL VPN is commonly for remote user access. It can provide access through web browser or VPN client. It's useful when users need to access to specific applications or resources. Organizations choose the appropriate technology based on user requirements, application being accessed, security requirements, and the type of remote device. 8.2.3 Site-to-Site IPsec VPNs. This figure shows a site-to-site VPN using IPsec. VPN gateways at both locations create and maintain the secure tunnel. The IPsec tunnel crosses the public internet and encrypts traffic between the two networks. The client does not initiate VPN and does not need VPN software. The client simply sends normal network traffic to the local VPN gateway. The VPN gateway handles encryption, authentication, decryption, and tunnel management. This type of VPN is commonly used to securely connect branch office to the headquarters and office to office. The VPN gateway encapsulates and encrypts outbound traffic. It then sends the traffic through a VPN tunnel over the internet to a VPN gateway at the target site. Upon receipt, the receiving VPN gateway strips the header, decrypts the content, and relays the packet toward the target host inside its private network. Site-to-site VPNs are usually created and secured using IPsec. 8.2.4 GRE over IPsec. Generic routing encapsulation, that's GRE, is a non-secure site-to-site VPN tunneling protocol. It can encapsulate various network layer protocols. It also supports multicast and broadcast traffic, which may be necessary if the organization requires routing protocols to operate over a VPN. However, GRE does not by default support encryption, and therefore it does not provide a secure VPN tunnel. A standard IPsec VPN non-GRE can only create secure tunnels for unicast traffic. Therefore, routing protocols will not exchange routing information over an IPsec VPN. To solve the problem, we can encapsulate routing protocol traffic using a GRE packet, and then encapsulate the GRE packet into the IPsec packet to forward it securely to the destination VPN gateway. The term used to describe the encapsulation of GRE over IPsec tunnel are passenger protocol, carrier protocol, and the transport protocol, as shown in the figure. The figure shows how GRE encapsulates one packet inside another packet for transport across a network. For the passenger protocol, the original packet being carried through the tunnel. In the figure, That's the IP plus TCP plus data. For the carrier protocol, the tunneling protocol that encapsulates the passenger packet. In the figure, this is GRE. And for the transport protocol, the protocol used to deliver the encapsulated packet across the network. And this is the IP. This figure shows a GRE tunnel protected by an IPsec VPN between a branch office and the headquarters. The branch office has an IP of 192.168.1.0/24. And the headquarters network is 10.10.10.0/24. The original IP packet travels between the two private networks. The GRE tunnel that encapsulates the original IP packet creates a logical tunnel between the branch and the headquarter routers. It can carry traffic that basic IPsec alone may not handle as flexibly, including multicast and routing protocol traffic, and does not provide encryption by itself. And for the IPsec VPN that protects the GRE tunnel as it across the internet, it provides encryption, authentication, and data integrity. So the original IP packet goes to the GRE encapsulation, and then goes to the IPsec protection, and at the end reach to internet. At the headquarter router, the process is reversed. First, it takes a IPsec decryption, and then GRE decapsulation, and now it can retrieve the original IP packet. The Wireshark screen capture in the figure displays an OSPF hello packet that was sent using GRE or IPsec. In this example, the original OSPF hello multicast packet was encapsulated with a GRE header, which is subsequently encapsulated by another IP header. This IP header would then be forwarded over an IPsec tunnel. Site-to-site IPsec VPNs and GRE or IPsecs are adequate to use when there are only few sites to securely interconnect. However, they are not sufficient when the enterprise has many more sites. This is because each site would require static configuration to all other sites or to the central site. Dynamic Multipoint VPN, the DMVPN, is a Cisco software solution. Building multiple VPNs in an easy, dynamic, and scalable manner. Like other VPN types, the DMVPN relies on IPsec to provide secure transport over public networks, such as the Internet. This figure shows a hub and spoke VPN topology, commonly used to connect multiple branch offices. The hub, that's the center router, usually located at the headquarters or main site. Spokes, those are the remote or branch office routers. In this figure, they are spoke A, B, and C. Each spoke establishes a VPN tunnel to the hub. The hub acts as the central connection point for all the spokes. The design reduced the number of VPN tunnels compared with the full mesh design. And let's talk about the spoke-to-spoke communication. Normally, if a spoke A wants to communicate with spoke B, the traffic goes spoke A to the hub and then spoke B. This can be very inefficient because traffic must go through the hub even when the two spokes could communicate more directly. Each site is configured using multi-point generic routing encapsulation, the MGRE, where the MGRE tunnel interface allows a single GRE interface to dynamically support multiple IPsec tunnels. Therefore, when a new site requires a secure connection, the same configuration on the hub site would support the tunnel. No additional configuration will be required. This figure shows how the DMVPN improves a traditional hub-and-spoke VPN. The green lines are the permanent connections between the hub and each spoke. The orange dashed lines are the dynamic spoke-to-spoke tunnels, created when direct communication is needed. Initially, each spoke communicates with the hub. When two spokes need to exchange traffic, DMVPN can dynamically create a direct tunnel between them. After the direct tunnel is established, traffic does not need to pass through the hub. Like DMVPN's IPsec virtual tunnel interface, the VTI simplified the configuration process required to support multiple sites and remote access. IPsec VTI configurations are applied to virtual interface instead of the static mapping that IPsec sessions to a physical interface. IPsec VTI is capable of sending and receiving both IP unicast and multicast encrypted traffic. Therefore, routing protocols are automatically supported without having to configure GRE tunnels. IPsec VTI can be configured between sites or in a hub-and-spoke topology. This figure shows an IPsec VTI connecting a branch office to the headquarters. VTI is a logical router interface associated with an IPsec tunnel. The traffic first enters the branch router through an interface. The router uses the routing table to determine where the packet should go. The packets destined for the remote network are routed to the VTI. The IPsec VTI encrypts the packets. The encrypted packets are then sent through the router's physical exit interface across the internet. At the headquarter router, IPsec decrypts the traffic and forwards the original packet to the destination network. Traditional service provider WAN solutions such as lease line, frame relay, and ATM connections were inherently secure in their design. Today, service providers use MPLS in their core network. Traffic is forwarded through the MPLS backbone using labels that are previously distributed among the core routers. Like legacy WAN connections, traffic is secure because service provider customers cannot see each other's traffic. The MPLS can provide clients with managed VPN solutions. So, secure traffic between client sites is responsibility of the service provider. There are two types of MPLS VPN solutions supported by service providers, and these are the Layer 3 MPLS VPN, also the Layer 2 MPLS VPN. For Layer 3 MPLS VPN, the service provider participates in customer routing by establishing a peering between the customer's router and the provider's router. Then customer routes that are received by the provider's router are then redistributed through the MPLS network to the customer's remote locations. And for the Layer 2 MPLS VPN, the service provider is not involved in the customer's routing. Instead, the provider deploys a virtual private LAN service to emulate an Ethernet multi-access LAN segment over the MPLS network. No routing is involved. The customer's routers effectively belong to the same multi-access network. This figure shows multiple customer sites connected through a service provider's MPLS VPN network. The MPLS VPN allows geographically separated locations to communicate through a service provider's private network. the customer sites connect their routers to the provider's MPLS network. The service provider carries traffic between the different locations. MPLS forwards the traffic using labels, allowing the provider to efficiently separate and route customer traffic.